Okay. Okay. Now we have put it over number 1 to q. What is this q? This is called number of degrees of freedom. I shall explain what is this. Take for example a molecule like CO2. You have only 3 atoms. The number of vibrational frequencies are called 3n minus 5. That means, look at it, 1, 2, 3. 3 into 3, 9, minus 5. That means there are 4 degrees of freedom for this one. What it means, let me explain. This carbon dioxide molecule, you can imagine, look at it. This is C, this is oxygen, this is oxygen. Okay? It can do, this is called a stretching. This is one type of vibration. Then look at it. Look at it. When this is going, this can go like this. This is called asymmetric stretching. Let me explain. Look. When both go like this is called symmetric. When this goes, this can come here. This is called asymmetric stretching. Then it can do bending. It can do bending also. So these are the 4. So it has 4 degrees of freedom. One, then this you can put like this. This is stretching. Okay. Then look at it. This is asymmetric stretching. This is symmetric stretching. This is asymmetric stretching. Then look at it. This is how we represent it. This is bending. Okay. I can represent this one in this diagram, very good diagram. Now imagine light is coming like this. For this kind of configuration, when light is going here, what would happen is, look at it, this will go like this. It will push like this. Then mu is 0, so du by dq is 0. On the other hand, the alpha is like this. So dou alpha by dou q is not equal to 0. Just remember this one. With this, we will explain a few more things and then we can come back. Q represents the coordinate of this molecule. Now, Q, N, T becomes Q, N naught, cos omega n t. What is this cos omega n. This represents molecular vibrational frequency. It is vibrating, that's all it means, with certain frequency. It's like a spring which is going like this or bending like this. It's a vibrational frequency. Then, go back to that equation. P has to be represented like this one, mu naught plus sigma n is equal to 1 rho q by rho q1 q n cos omega n t plus t plus. Now imagine you are sending a light of omega, frequency omega. This is a light, not necessarily laser light. Then the net effect will be 1 by 2 V naught sigma rho alpha I j by rho q n. Q n 0 cos, this is a light of frequency, let me say this is V naught cos omega t. Remember, omega t is different from omega in t. This is for laser light. I can put L to avoid confusion. This is L. L may be light or laser. It can be anything. Whereas this one is for the molecule. That is, a light of certain frequency omega is interacting with molecule of certain frequency omega. Right, then you can easily do the rest of this. This will be cos omega plus omega n t plus cos omega minus omega n t. Now you can see this represents the infrared frequency corresponding to the vibrational frequency of the molecule. So this represents the light corresponding to IR frequency of molecule. This represents the light. Remember, this is represent the light which has the same frequency as the incident light. This is called Raleigh's scattering. There's no change in wavelength or a frequency. On the other hand, here is another frequency which is sum of the two frequencies. This is omega plus omega n. Here is another omega minus omega n.
Raman.
Huh?
Raman's.
These two are Raman. Now, you see the funny point? Now, when you say Raman, what do you come across? Immediately you should try. Instead of light, if I use laser, what is this one?
A new laser.
This is a parametric generation.
Yes, parameter.
Understand? Instead of using the crystal, I don't have to go to his lab, Nazaruddin lab. You understand?
Yes.
What is he doing? You send a laser light, put a crystal, then he gets two frequencies, one step more, one step less. You get two additional frequencies depending upon the natural frequency of the crystal. Understand?
Yes.
Now, same thing I do here. I take not crystal, I can take any liquid, alcohol, gas, solid, anything, I can get two more frequency, which will be the sum of the, and another one is a difference frequency. That means
What's the best for the use?
later, one by one. Later. Okay. So Raman laser is a parametric generator. Okay. Parametric generator. I will stop with this one. Next lecture, we will see more. Okay.
Thank you, sir. Thank you.
Oh, next lecture, that will be
Monday, sir.
Huh?
Monday.
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 He is leaving on something Monday. Okay. Now what is this one?